It's showing up on the back screen, but I don't know what happened. Okay. Okay, I'm sorry, I'm having some technical problem. I need to call the technology service. I think it will take a few moments, okay? 2, 3 minutes. I'm sorry. Okay, hello everyone. Good afternoon. I'm really sorry about that. Actually, the projector has some issues and the projector is not working. So we are a little bit late. It's already 2:10. Okay. So in the last class, um, we discussed about the standard deviation and sample variance. So we'll continue from there. So we went over an example and which was about the house prices, I think. So we showed how to calculate the sample variance and sample standard deviation. So now we'll go over how to calculate the quartiles because we need quartiles for the 5-number summary and for the box plot. So to calculate the quartile, you need to arrange the data in ascending order or increasing order or decreasing order and look at the median. So find the median. You already know how to find the median. And then you will have two data set because the median will divide the data set into two parts. You will have one data set on the left side of the median and one data set on the right side of the median. So you will calculate the median for each part of the data set. And if you calculate the median for the left, for the data set which are left on the overall, left to the overall mean, overall median, and that median will be Q1. And for Q3, you have to calculate the median for the data set on the right side. Okay. So once you have the minimum value, maximum value, the quartiles, and the median, then you can write the 5-number summary. And the 5-number summary is minimum Q1 x tilde is the median, or you can say this is Q2, which is median. So this is also Q2 or x tilde, and Q3 and the maximum value. So based on this 5-number summary, you can construct the box plot. So box plot is a graphical representation of the data. So in the box plot, you will have minimum value, maximum value. So first you have to locate the minimum value, maximum value, Q1, Q2, Q3. And to draw the box plot, so once you have Q1, Q3, and Q2, so first you need to write this one will be the minimum, and this is the maximum value. This is max. So then you have to locate Q1. For example, if Q1 is here, then Q2, which is the median, and this is Q3. You have to locate Q1, Q2, Q3. Then you will draw a vertical line here, and vertical line here, and vertical line here. Then you will add this line together. So that will be the box plot. So this is called a graphical representation of the data set. So we'll construct a box plot for our example. So here we have an example, and we have the data set here. So first you need to calculate the median. So here median is 1.4. So we went over this example in the last class. So to calculate Q1, you need to include this number in the left side of the data set, and to calculate Q3, you have to also include this value to the right. So we have this data set on the right side and this data set on the left side. So now we'll calculate the median for this data set, and which is negative 1.5. This is our Q1, first quartile, and it will calculate the median for this data set. Sorry. And the middle value of this data set is 3.7, which is our third quartile. And the minimum value is negative 12 here, and the maximum value is 7. So we have all 5 numbers. Now you can write your 5-number summary. So this is the minimum value, this is the maximum value, this is our Q1, this is Q2, or x tilde, and this is Q3. So we have this 5-number summary to construct the box plot. So first you will put this number on the number line. So our minimum is -12 and maximum is 7. So you need, on the number line, you need number from -12 to 7. So here we have okay. So this is -10. So our minimum number will be somewhere here. So this is our -12. This is the minimum number. And Q1 is -1.5. So this is 0. So -1.5 will be somewhere here. So this is 2. So -1.5 will be somewhere here. So that's why this is our Q1. And 1.4 is, this is 0. So this is 2. So 1.4 will be somewhere here. So that's why we have Q2 here, or x tilde is here. And then you have to look at Q3. So Q3 is here, which is 3.7. Then you will draw the box plot. So this is our box plot. So you can use this box plot to compare two data set. So you can compare the center of two data set. You can also compare the spread of the data set based on the box plot. Okay, so if you consider the example, so we had two data set in that example. One data set is from Big Bank. The other data set is from Best Bank. Okay, so from the Big Bank, you can calculate the 5 numbers. And from the Best Bank, from the data set of the Best Bank, you can also calculate the 5 numbers and use these 5 numbers to construct the box plot. So here we have 2 box plots. So this box plot is for, this is for Best Bank, and this is for Big Bank. So now if you look at these 2 box plot, then you can compare the location, the center, and you can also compare the spread. So you can see the center is here, the median is 7.2. So both are same here. And you can also see, you can also compare the maximum and minimum value for both data set. And if you look at these 2 box plot, you can see that the variability for the Big Bank is way larger than the variability of the Best Bank. So if you look at the box plot of two data set, then you can compare the 2 data set. You can compare the variability, and you can also compare the center of the data set. So this is graphical representation of data sets. And this is useful to compare the data set with a small size. Okay, so the next thing is, this is called the fourth spread or interquartile range. This is called IQ, interquartile range. So what is interquartile range? The difference between the third quartile and the first quartile is called the interquartile range. So here Q3 is the third quartile and Q1 is our first quartile. So if you take the difference of these 2 numbers, it is our interquartile range, which can be denoted as IQ, or you can also use this notation for interquartile range. So interquartile range is important to calculate the fourth spread. This is considered as fourth spread. And we use this one to find the outliers in our data set. If there is outliers in our data set, you can use interquartile range to see which values are outliers. Okay, so an observation will be considered as outlier if the distance of this value from the nearest quartile is more than 1.5 times of interquartile range. So if you will calculate the interquartile range and you will multiply with 1.5, and you will see that if the distance of a value is more than 1.5 times of the interquartile range from the nearest quartile, then it will be considered as outlier. So for example, if you go back to the box plot, okay, so I can just draw a box plot here. For example, if we have a box plot here, so this is our Q1, this is Q3. So now the interquartile range is, this distance is interquartile range. This is called Fs. This is interquartile range. Now, if values, for example, if we have a value here, and the distance of this value from the first quartile, if this distance is more than 1.5 times of interquartile range, then it will be called outliers. And your data might have extreme outlier. So if the distance of a value from the nearest quartile is more than 3.5 times of interquartile range, then it is called extreme outliers. So if the distance of a value or of an observation from the nearest quartile is more than 1.5 times of interquartile range, then it is called outlier. If the distance is more than 3.5 times of interquartile range, then it will be called extreme outliers. So if your data set has extreme outliers, then the mean of the data will be affected by the outlier. So in that case, you have to be very careful when you will be calculating, or you will be explaining your data, or you will be calculating the descriptive statistics of the data, or when you will be making inference about the population based on these descriptive statistics. So that's why knowing about the outliers or having knowledge about the outliers is really important. Okay. So S squared, the sample variance, and S are the best used to describe the spread of relatively symmetric data set. So if you have a symmetric data set, then as a spread or variability, you can use variance, sample variance, or sample standard deviation. Okay, and S should be used with X bar. So when you will calculate standard deviation and variance, you will use X bar, not the median. So when you will be taking the difference of the center from the data, you will be taking the difference of data of observations and the mean, not the median. But if you have skewed data and if your data set is not that large, then you can use 5-number summary, and that will be best used for skewed distributions, or if your data set have outliers. Okay, because if your data set has outliers, then you can also, in that case, on the box plot, we use actually asterisk sign. For example, if you have outliers on the right side, then if there is just one outlier, then you will be using just one asterisk sign. Or if you have two outliers, then you will be using two asterisk symbol. So this means if you have this symbol on the box plot, so that means the data set has outliers. Do you have any question? Okay, so this is all about the first chapter. You have, okay, so I have already extended the due date of the first homework, and it will be due on Friday. So you will have two homework on Friday. So the first homework and the second homework. That's mean homework 1.1a and 1b. Okay, so if you do not have question, then we'll move to the next chapter. The second chapter is about probability. Okay, so you do not need to type present unless I ask you to type present, okay? Okay, the second chapter is about probability, and in the first section, we'll cover the sample spaces. So before doing any problems related to probability, you need to know the sample space and events. So we'll discuss about this in the first section, and in the second section, we'll discuss about the properties of the probability, and we'll calculate some probability and the basic some basics formula of the probability. Then in section 2.3, this is about counting techniques, but we are not going to cover this section in this class, in this course. And in section 2.4, we'll discuss about conditional probability. And in section 2.5, this is about independent probability of independent events. And this is also important for calculating the conditional probability. Okay. So what is sample space? So before discussing the sample space, I want to give you an idea about experiment. So experiment means if you okay, so first you need to know about the outcomes. So if you do an experiment okay, sure. Oh yeah, yeah. Thank you so much. Yeah, thank you. Yeah, I forgot to actually change the screen share. Yeah, thank you for letting me know. Yeah, I should be very careful. So are you seeing chapter 2 now? Yes. Okay, thank you. Okay, so if you toss a coin, so the coin has two sides, head and tail. So if you toss a coin, there are two outcomes. So the possible outcomes are, so head and tail. Either you will get head or tail, right? So that's mean you have two outcomes. So if you toss the coin twice, then the possibilities are, if you might get so then you might get, for the first coin, you might get head, and for the second one, so here H denote head and T denotes tail. So H is the head of the coin and T is the tail of the coin. Okay, so if you toss a coin twice, then you might have both head. First one is head, second one is tail. First one is tail, second one is head, and both are tail. So these are the possibilities you might have, right? So these are the possibilities of the outcomes. So the set of all possible outcomes. So this is actually the set of all possible outcomes. And to write a set, usually we use curly bracket. So to write a set, we use this bracket, the curly bracket. Yeah, actually this is not very nice one. Yeah, it should be like this. So, and you will separate the outcome with a comma. So you can see that the first outcome is HH if you toss a coin twice. then you will have either both head, head, tail, tail, head, or both tail. So you will separate the outcome with a comma. So that's the way you will write the sample space or events of an experiment. Okay, so event and sample space are different. I will discuss about it. So now the sample space is set of all possible outcomes. So this is the sample space for the experiment where we toss a coin twice. So this is the sample space, and sample space is always denoted by S. So in this case, the S is equal this set. So this is our sample space. Now, if you roll a die, if you roll a dice once, then a dice has 6 sides, and each side has, if you denote each side with a number, so if you denote one side with 1, the other side with 2, 3, 4, 5, and 6, since it has 6 sides, then so you need 6 numbers to denote all 6 sides. Now, if you roll a dice, then you might have 1, 2, 3, 4, 5, or 6. So our sample space will be S is equal. So this is our sample space in this case. So now if in our experiment, if you want to know the gender of 2 kids, then the possible outcomes will be both are boy, and first one is boy and second kid is girl, and first kid is girl, second one is boy, or both of them are girls. So these are the all possibilities. So in this case, the sample space will have 4 outcomes in our sample space. So S will be this set here. So what is the event? Event is any collection of outcomes from the sample space. So if you collect any outcomes and write as a set, then it will be called the event. For example, so if you consider the first experiment, which is we tossed a coin twice. So in this case, the sample space is this one. So for example, if our event, and events are denoted by capital letters A, B, C, D, E, F. So you can denote events with these letters. So for example, if an event A is both are head. Okay, so in our experiment, if we want to know the outcomes where both are head, then this is called an event. And how many outcomes we'll have in this case? Just one, right? HH. So this is actually the subset or collection of outcomes from the sample space, right? Because we collected one outcome from the sample space, and this is also called the subset of the sample space, right? So if you take any subset of the sample space, then it will be called an event, and sample space itself is an event. Okay, so now there are different type of event: simple event and compound event. So what is simple event? If the event contains exactly one outcome. So for example, if you consider the experiment rolling a dice, then in this case, how many simple events we can have? 6. Yes, we can have 6 simple events, right? Because we have total 6 outcomes here. So, and if the event contains exactly one outcome, then it is called simple event. So how many events we can make with 6 outcomes? We can make 6 events, right? Yeah, so we can have 6 simple events in this case. And compound event consists of more than one outcome. If the event has more than one outcome, then it is called compound event. For example, we have several examples here. So for the first experiment, the event A is equal roll an even number. So we have three even numbers here, 2, 4, 6. So if you take the collection of these three outcomes, then the set A will be 2, 4, 6. So this is compound event, right? Because we have three outcomes here in this event. This is not a simple event. This is compound event. So how about B? Event B is roll an odd number. So that's mean 1, 3, 5. This is also compound event because we have three outcomes here. And C, roll a 3 or higher number. So that's mean 3, 4, 5, 6. So that will be the outcomes in this event. So this is also compound event. And D and E, they came from the experiment of knowing the gender of two kids. So here D is same gender. So that's mean both are boy and both are girls. So this is also compound event. B, B, G, G. And E is at least one boy. So that's mean in our outcome, we can have two boys. First one is boy, second one is girl, and first one is girl, second one is boy. There should be at least one boy in the outcome. So in the first one, we have two boys. So we will also, this event also contain this outcome. So this event contain three outcomes. So this is also compound event. So do you have any question? Okay. So now, complement of an event. So how many of you have idea about set theory? Different union of two sets, intersection of two sets, complement of a set. So did you learn about this? The set theory? Okay, then yeah, maybe some of you do not know what is set theory and what are the set operations, right? So I should discuss a little bit more about this. Okay. So complement of an event. Event also is a set. The sample space is also a set. So the complement means the sample space is the actually the largest set of an experiment. So for example, if we consider rolling a dice, 1, 2, 3, 4, 5, 6. So this is our sample space. So here event A contains 2, 4, 6. So the complement of A will be the complement of A, and the complement is denoted by, this is called A prime or A dash. This is called A prime or A dash. So this is actually the symbol of complement. So A prime or A dash means a complement. So a complement will be actually the rest of the outcomes which are not in the event A. So that's mean the outcomes, set of all outcomes in the sample space not contained in that event. So here A contains 2, 4, 6, and in the sample space we have 1, 2, 3, 4, 5, 6. So that's mean the outcomes which are not in the set A will be 1, 3, and 5. Now you can see actually B is the complement of A, right? But it's not always true. But here in this case, B is 1, 3, 5. So B is complement of A. You can also say instead of B, you can say this is A prime because B is complement of A. So our set C has 3, 4, 5, 6. So the complement of C will be then C prime or C dash will be just 1, 2. And similarly, B prime will be, or B complement will be, B has 1, 3, 5. So 2, 4, 6 will be the complement of B. And this is also set A. So B complement and A are same. And for the second experiment, complement of D is D prime will be this one. So this is the complement of D. Do you have any question? Because you will be using actually this uh, the complement, the union, and the intersection in this chapter frequently. So you should know about the complement, union, and intersection. Okay, so union of event A with event B. So that's mean union of two events or union of two sets. So what is the union of two event? So union of two event is set of outcomes contained in A, in B, or in both. So that's mean you have to collect all the outcomes which are in A and also in B, but you do not need to write the same outcome twice. So now if you take the union of A and B, then it will be the A has outcome 2, 4, 6 and B has 1, 3, 5. So the union will be then the collection of all outcomes which are in A and also which are in A and in B or in both. So we have 2, 4, 6 in A, we have 1, 3, 5 in B. So A union B will be 1, 2, 3, 4, 5, 6. Okay, so in A union C, so in A we have 2, 4, 6. So here we have 2, 4, 6. And in C we have 3, 4, 5, 6. So we have 3, 4, 5, 6. But you do not need to write the same outcome twice. So that's why we didn't write 4 and 6 twice, right? Because 4 and 6, 4 and 6 are also in A and in C. But you do not need to write it twice. So A union C will be then 2, 3, 4, 5, 6. So D union E will be then this one. D has this 2 outcome and E has this 3 outcome. But this outcome is common in both events. So you do not need to write this outcome twice. You just write this one once. So you will have total 4 outcomes here. And this is actually the sample space. So intersection of event A with another event B. So, okay, the union is denoted by A. This is called union B. This symbol is like U, capital U. And this is called union. And you will read this one as A union B. Or this can be also written as A or B. Or also means the union of these two sets. Okay. And intersection is denoted by, if you take the reverse of this notation, the U, then it will be intersection. So this is called A intersection B. You can also write this one as A and B. So either you will write A, you will use this notation, or you can also write A and B. So that's mean the intersection of these two sets. So what does the intersection means? Intersection means the common outcomes between two sets. If you take the intersection of two sets, then the common outcomes between two sets will be the intersection. So if you take A intersection B, then there is no common outcome, right? There is no common outcome in A and B. So that's mean it will be empty set, or this is called phi or empty set. So empty set means if you write this notation, that means this is empty set. It doesn't have any element, right? This set doesn't contain any element. Or you can use this notation. So this is called P or empty set. Okay, but if you write this notation like this, then this is not correct. This is wrong, because this means this is a set which has one element. The element is P. So either you will use this notation or this notation, but you cannot use both of them together to denote the empty set. Then it will be wrong, because this notation is not correct. This means actually this is a set which has one element, which is P. Okay, so since A and B doesn't have any common outcome, so it will be, the intersection will be empty set. So this is empty set, so you can use this notation or phi. And A intersection C, A has 2, 4, 6, and C has 3, 4, 5, 6. So here the common outcomes are 4 and 6. So that's why A intersection C is 4, 6. And D intersection E is BB, because it has just one common outcome. So the intersection will be this outcome. Now the mutually exclusive event. This is also really important in probability, mutually exclusive or disjoint event. So what is mutually exclusive event? If any two events do not have any common outcomes, then they will be called mutually exclusive. That means they do not have any common outcomes. They are mutually exclusive. So that means if you take intersection of two events, and if the intersection is empty set, then they are called mutually exclusive event. And their probability is 0. We'll discuss about this later, the probability of two mutually exclusive event. And here A and C, if you take the intersection, it has 4 and 6. So it is not empty. So that means they are not mutually exclusive. And when you will be calculating the probability of union of two sets, you will need this information, whether they are mutually exclusive or not. If they are mutually exclusive, you will have one formula. And if they are not mutually exclusive, you will have different formula to calculate the probability of A union B. So this is really important when you will be calculating the probability. Okay, so now Venn diagrams. To represent the event, you can use set notation, or you can also use diagram notation, which is called the Venn diagrams. So you can represent the union of sets, the intersection of sets, using some diagram, and this diagram is called Venn diagram. And this Venn diagram is this is actually very useful when you will be calculating the probability, because sometimes it is really tough to calculate the probability just using the formula. So in that case, you can use the Venn diagram and you can easily calculate the probability, and you will see that, and we'll go over some example, and you will see this whether the Venn diagrams are really useful. So what is Venn diagram? So to draw a Venn diagram, you will use a triangle shape to represent the sample space. Sorry, not triangle, rectangular shape. So you will use a rectangle to represent a sample space. So this is called a sample space. So that means this rectangle will contains all the outcomes of an experiment. So that means you will have all the outcomes of an experiment in this rectangular box. Then you will usually we use some circle to represent the events. So here we have two events. One is A, the other one is B. So A, B. So this rectangular box is sample space, and this circle is A and this circle is B. Now we can see there is an overlap, right? So what does this mean actually? This means these two event has common outcomes. So that's mean A and B has some common outcomes. So that's mean they are not mutually exclusive. And these parts represent the intersection of these two sets. So that's mean this part, the common part, the overlapping part represents actually A intersection B. And A and B together, this whole area, this area represents actually A union B. A union B. And this part in the middle, this represents A intersection B. Okay, so here now you can see this is A union B. This shaded part is A union B. And because this shaded region contains all the elements which are either in A or B or in both. Now, if you look at this diagram, you can see there are no common pairs between A and B. So that's mean they are mutually exclusive. So that's mean their intersection is empty. So this diagram means they do not have any common pair. So that's mean A intersection B is empty. They do not have any common outcomes. And this is A intersection B. There is some overlapping part. So that's mean they have some common outcomes. So this overlapping part is the common outcome between A and B. So that's mean this is the intersection of A and B. And the complement of A. So that's mean all the outcomes which are not in A but in the sample space. So that's mean the outside the sample space. So that's why A complement is the shaded region which are outside A. And the white region is A, and the outside region is A complement. Okay, so actually the first section is all about the set operations and set notations. So here we discussed about the events, the sample space, the complement of a set or complement of an event, the union of two events or union of two sets, the intersection of two sets, and the mutually exclusive set, and how to use the Venn diagram to represent the sets and sets operations. Okay, in the second section, this is actually about probability of different events. So the probability of an event which is denoted by P of A. The probability of an event is denoted by P of A. So this is called probability of event A. So this notation is called probability of event A. And probability is always between 0 and 1. The probability cannot be more than 1 or cannot be negative. So it cannot be less than 0 or cannot be more than 1. So probability is always between 0 and 1. Okay, so when the probability of an event is 0, this is called if probability of an event is 0 or 1, if it is exactly 1, then it is called certain event. So that's mean it will surely happen. So for example, what is the probability that tomorrow is Wednesday? So what is the probability that tomorrow is Wednesday? 1, right? It's certain. Tomorrow is Wednesday. So that's mean in that case, the event is certain. So that's mean the probability is equal 1 because it is gonna happen. So when there is no chance that the event will occur, then the probability will be always 0. So for example, if we say tomorrow is Monday, or tomorrow, what is the probability that tomorrow is Monday? The probability is 0, right? Because we certainly know that tomorrow is Wednesday, not Monday. So it is not going to happen that tomorrow will be Monday. So the probability is for that event is always 0. And this event is called impossible event. When the probability is 0, it is called impossible event. And if the probability is 1, it is called certain event. Okay, so there are 3 general methods to obtain probability: long run relative frequency. So if you do the experiment again and again and again, for example, if you roll a die, you do not know whether or if you toss a coin, you do not know whether the um, coin is equally likely or whether the coin is biased or not. Then in that case, you can toss the coin maybe 100 times, 1,000 times, and you can see how many times the head occurs and how many times the tail occurs. Then you can calculate the percentage of occurring head and percentage of occurring tail. So if you do this experiment thousands times or 10,000 times, after that you can make a decision that the percentage of occurring head is, for example, if in 100 times, if you have 60 times head and 40 times tail, then based on this, you can say, okay, in the next toss, there is chance that we'll have head and the chance is 60%. And you decided this based on the experiment you have done, right? So this is called long run relative frequency. This is also actually relative frequency. So equally likely events. If all the outcomes has same chance of occurring, then this type of events are called equally likely events. In that case, for example, if the coin is a fair coin or unbiased coin, then if you toss the coin, then it has 50% chance that it will occur head, and it has 50% chance that it will occur tail. So this type of events called equally likely event. And the other one is subjective event. So that's mean a person will assume the probability in that case. Okay, so in our course, actually, mainly we'll be discussing, we'll be going over the equally likely events and the long run relative frequency. We might be using also subjective probability. So probability relationships. So till now the operations of events or operations of set, but now how do we calculate the probability for different set operations? For example, if A is an event, then A prime is the complement of A. So if you know the probability of A, then how can we calculate the probability of A complement? Okay, so before discussing this, I should mention that probability of, so what is the probability of sample space? What is the probability of sample space? Okay, so if you consider the example of rolling a dice, 1, 2, 3. Okay, so the possible outcomes are 1, 2, 3, 4, 5, 6. So now if you roll a die, so what is the probability that in this experiment, there will be either 1, 2, 3, 4, or 5 or 6. What is the sense, or what is the probability? Okay, yeah, if you consider there will occur only either 1, 2, then yeah, then it will be 1/6. That's fine. But my question is, if I roll a die, then it will um, appear either 1, 2, or 3, or 4, or 5, 6. So what is the probability? 1, right? Because it is certain that any of these 6 number might occur, right? So it is certain that either 1 will appear or 2 will appear, or among the 6 numbers, 1 number will appear, right? It is certain. So that's why the probability of the sample space is always 1. The probability of sample space is always 1 because you are considering all the outcomes in this event, right? So this is called the total probability. So this is always 1. So the probability of S is always 1. Okay. So now if the probability of A is, so A is an event, and we collected this event from this sample space. So, and if you consider the previous example, then A was 2, 4, 6, right? So what is the probability of A? Okay, probability of A is actually number of outcomes in A. How many outcomes are there in A? 3. So what is the total outcomes? 6. So the probability of A is 3/6. So that's means in the numerator it will be the number of outcomes in that event, and in the denominator the total number of outcomes in the sample space. So the probability is 3/6. So that's means this is 0.5, right? So now the total probability is 1, right? So what do we know about the complement? All the outcomes which are not in A, right? All the outcomes which are not in A. So then the complement will be 1, 3, 5, right? So what is the probability of A complement then? 0.5, yes, 3/6. Thank you. So this is 0.5. So this is one way of calculating the probability, but there is another way. So if you know the probability of an event, you can easily calculate the probability of the complement of that event, because the complement will be actually the total probability minus the probability of that event. Why this is true? Because if you think about the Venn diagram, then the total probability is 1. So that's mean the probability of this rectangle is 1. And this is, for example, this is A. So the inside area is A, the outside area is a complement, right? The outside is a complement and inside is A. And the total area inside the rectangle is 1. Okay, the total area of this rectangle is 1. So if the area of A is 0.3, for example, if the area of A is 0.3, then what will be the area of A prime? 1 minus 0.3, right? Because the total is 1. So the area for the A complement will be 1 minus 0.3, right? Is it clear? Okay, so that's why if you know the probability of an event, then the complement will be actually 1 minus the probability of that event. So now you can use this formula to find the probability of the complement of an event. So it is always 1 minus the probability of that event. So now the probability of A union B. So this is the formula, but you do not need to memorize it, but you can easily remember it. I will show you how to remember it. Okay, so A union B. So probability of A union B. I'm sorry, my drawing is very nice. So this is okay. Okay, this is rectangle. And this is circle. So this is A, this is B. Okay, and this is the, now we'll find the probability of A union B. Okay, so this is actually equal probability of A plus probability of B. Okay, so if I just write this, there is problem. So what is the problem here? So now we can if we use different color. Okay, for example, this is our A. This is our A. And the blue is B. Okay, so now if you write the probability of A, so that's when this is the probability of the red part, right? This is the area of this red part, right? And how about probability of B? This is the area of this blue region, right? Probability B is blue region, right? So now if you look at carefully, then you will see that in the middle we have red and blue, right? In the middle we have red and blue both, right? So when you are writing probability of A, so that's mean you are considering all this area, the red area. Now, when you are writing probability of B, so that's mean you are considering the blue region or blue area. So what is happening in the middle? When we add them together, we are adding the middle part twice, right? When we are writing A, we are considering the middle part, and when we are writing B, probability of B, we are also considering the middle part, right? So that's mean we are adding this area twice. So probability of A union B will be probability of A plus probability of B, but the problem is if we just add these two probability, we are writing the middle part twice, but we cannot do that. So you have to subtract this one once, A intersection, and the middle part is A intersection B. So that's why probability of A union B is probability of A plus probability of B minus probability of A intersection B, because when you add probability of A and probability of B, you are writing this one twice. So we subtracted this one once. Is it clear? Do you have any question? That's why in the formula you can see we have probability of A union B is probability of A plus probability of B minus probability of A intersection B. Okay, so in this case, they are not mutually exclusive event. Here they are not mutually exclusive event because they have common region. But if we have two mutually exclusive event, then what will happen to this probability formula? So okay, I should use different color. So this is A, this is B. Okay, so now if we write probability of A union B is equal probability of A plus probability of B. Is it correct or wrong? So am I writing any region twice here? No, because A and B, they do not have any common part. So when I'm writing probability of A, I'm just considering this area. And when I'm writing probability of B, I'm just writing considering this area. So that means if we add these two probability together, we are not adding any area twice. So that means this formula is correct. So now we have two formulas for probability of A union B. So one is probability of A plus probability of B, and the other one is probability of A plus probability of B minus probability of A intersection B. So now the question is, when do we use the first one and when do we use the second one? The first one is for mutually exclusive event, right? This is for mutually exclusive event. So when you will have two mutually exclusive events, if you want to find the probability of the union of these two events, then it will be just you will be just adding the probability of these two events. But when they are not mutually exclusive, so that means A intersection B is not empty. In that case, you will have this formula. Or if you forget about the Venn diagram, so if they are mutually exclusive, then A intersection B is empty. A intersection B is actually empty when they are mutually exclusive. So A intersection B is empty means the probability of this part is 0. So probability of this one is equal to probability of empty set, which is always 0. Because this is impossible event. This is not going to happen because there is no outcome actually. So the probability is 0. So if you write this probability when they are mutually exclusive, actually probability of this part is 0. So that means actually we do not have this part, right? We do not have the intersection part in this formula. So for A union B, you have two formulas. One when the first one when they are mutually exclusive, and the second one when they are not mutually exclusive. Okay, so there is another probability relationship. So it is probability of, now if we have three sets or three events and we want to find the probability of the union of these three events, then how do we calculate the probability? Then you have to calculate probability of probability of A union B union C. You will add the probability for each. We'll calculate the probability separately for each one. We'll add them together. Then you will subtract the intersection between any two events, and you will add the probability of the intersection of all three events. So actually, why do we have this formula? I can also, you can also see if you construct the Venn diagram. So I'll show you this one. So we have three events here. 1, 2. It's better using if I use different color. Okay. So this is A. This is B. And blue is C. Okay. So now you see that probability of A union B union C is equal probability of A plus probability of B plus probability of C. So when you are adding them together, so what is happening here actually? So if you shade them, this is red, this is our A. So this is our A. Then this is our B. Then this is our C. Actually, what is happening here? So if you look at the color, so how many colors do we have in this region? In this part? Okay, I should use different color here. So how many colors do we have in this part? Only two colors, red and yellow, right? So we have red and yellow. So that's mean we are adding this probability twice, right? So we need to subtract this one. So that's mean minus probability of, and this is actually, this part is actually this part is intersection of A and B, right? So A intersection B. Similarly, we'll subtract this part because we are adding this part twice, right? So that's mean probability of, this is actually B intersection C, minus probability of, we need to also subtract this part because we have added this part twice. So that's mean probability of A intersection C. Okay. So now you can see here we have actually three colors, right? So how many times we added this part? 3 times. How many times we subtracted this part? 3 times. So that's mean actually we are not considering this probability yet, right? Because when we added these 3 probabilities, we added this part 3 times. But when we subtracted this one, we subtracted this one as well. When we subtracted this region, we subtracted this one. So when we subtracted this one, we subtracted this one as well, right? So that's mean we added this area 3 times and we subtracted this area 3 times, right? So this area is not in the formula yet, right? Now we need to add this part. So what is this part? This is the intersection of all 3, because in this region we have all 3 colors, right? So that's when this is the intersection of all 3. So you need to add this one again. So probability of A intersection B intersection C. So actually that's why we have actually this formula. Okay, so do you have any question? Actually, you should really understand the Venn diagram, because to calculate the probability, you will be using the Venn diagram. So you should have very good understanding of the Venn diagram. So if you have any question, so tomorrow you will have office hour from, I think 11 to 12:30 or maybe 11:30 to 1. But I will be available from 11 on Zoom. So if you have any question, you can just join the Zoom meeting. So then I will get an email and I will also join the Zoom meeting. Okay. Yeah, sure. Okay. For Thursday quiz, we'll just go over the chapter 1, the first chapter, and you will have maybe 1 or 2 questions, and it will be one web assignment. So maybe the last 20 minutes will be the quiz. Yeah. Okay, and it is open book and open note, so you can use the book and note for the quiz. Okay. Do you have any other question? Sorry. Oh yeah, thank you. Yeah, I didn't take the attendance for today. Okay, so if you didn't type present yet, please type present. Okay, thank you. Okay, I'll stop here today. can come in. The projector is not working. Yeah, I called them and already she told me that we have to use the manual button or something for the alternating projector or something, but I didn't find it yet.
Okay.
Yeah. Oh, maybe that was.
She said she, we have a coworker that taught here this morning.
And she told me that she also doesn't know how to turn on this one. So,
And so, do you think you turned it on? And she said you can't, like, you only need about half the screen. But if you're, okay. Our life is an adventure, everything is an adventure.